My dear students and a learner, today we are going to discuss about one of the important topics is a wave numbers of IR spectroscopy. Here my intention is very clear, not to discuss the IR spectroscopy, but I only focused on those values of a wave number which is used in a IR spectroscopy. So many times the question was asked in GPAT and NIPER examinations, and so many competitive examinations or exam values of different wave number was asked. Today we will see how this wave numbers for different functional group are there. So IR region is basically a two main region. So if we can say that the region is divided into two portions or two parts. One is a functional group region and another one is a fingerprint region. So normally to make a scale a very broad, we have a value from 4000 centimeter inverse to the 400 centimeter inverse. Among them, if you see, there is one place 2400 centimeter inverse, then 1400 centimeter inverse, just to show you how this is all this value I have taken, that is based on the 4. So if we see here, then this value or values we can say from here to this one up to this is known as what? This is known as a functional group regions. Then 1400 to 400, that is known as a, उसको बताता है कि वो of fingerprint region है. I discuss here only about this one, and that is also in terms of functional group determinations. The fingerprint is used for not identification of the functional group, but to match the compound. So my first and foremost, or my intention here, to show you something highlights between this group. I have divided this group in total of 4 zones also. Let us see how it is. If we see here, then IR spectroscopy are basically work on a stretching and bending frequency. So I have carbon, then nitrogen, then oxygen and fluorine. These are the element I have written according to the periodic table. Then one more, we have hydrogen also. So normally हम ऐसा सोचते हैं कि हमारे पास दो तरीके की लकड़ियां हैं. One is a short stick and another one is a long stick. Among the short stick and among the long stick, if we see here, then it is very easy to vibrate or stretch a long stick compared to lakdi, compared to a choti si, compared to the short stick or choti si lakdi. तो इसमें हम यहाँ से बताते हैं कि ये एक ऐसा बॉन्ड है, एक ऐसा बॉन्ड है. इसमें कम एनर्जी चाहिए, इसमें ज्यादा एनर्जी चाहिए. इसमें कौन सी एनर्जी चाहिए हमको? ज्यादा एनर्जी चाहिए. सो फर्स्ट आई विल मेक अ ग्रुप, हाइड्रोजन विथ अ कार्बन, हाइड्रोजन विथ अ नाइट्रोजन, हाइड्रोजन विथ oxygens, and hydrogen with this fluorine is there, but it is a inorganic component, so it is not our interest. This all carbon with hydrogen, nitrogen with hydrogen, oxygen with hydrogen, they all comes at this group. Okay, so I am focused at here. They are come in the range of 3000 to the 4000 centimeter inverse. Always a unit is centimeter inverse. Then we think about carbon make after the short, or we can say after the bond length. Another parameter is a number of bond is also playing a more role. So I can say carbon with nitrogen a triple bond, carbon with carbon a triple bond. So after that we have a triple bond, then we have double bond, then we have single bond. This is sp hybridized, this is sp2 hybridized, This is sp3 hybridizations. If you don't know hybridization, please see my video of the hybridization. So in case of sp hybridizations, here increase percentage s character, so increase or make a strong bond. It will make a strong bonding with another elements. I can say like this. So carbon with carbon triple bond and carbon with nitrogen triple bond, carbon with oxygen triple bond is not possible because oxygen is making only two bonds. So they are come at here. And let us go ahead and see. Again, a carbon triple bond is over. Now we move to the carbon double bond. So here a carbon with carbon double bond, carbon with nitrogen double bond, carbon with oxygen double bond, carbon with fluorine double bond is not at all possible. They all are come in these regions. So this is also possible. Carbon with nitrogen, then nitrogen with oxygens, all are come at here only. So broad way I can say this is sp-sp hybridization stretching. This is sp2 hybridization stretching. And here this is now a carbon with a single bond. So I can say carbon with single bond also we have to do like this. A carbon with carbon single bond, carbon with nitrogen single bond, carbon with oxygen single bond, carbon with fluorine single bond. Required a less energy, so they comes under this regions, or I can say this is sp3. Let us see, this is very broad. Now I bifurcate this all the range of a wave number of IR in a different four zone. Let us see the first zone 1. So in case of zone 1, there is a hydrogen with single bonded, all the elements are here. So we can say zone 1, it is further bifurcated. This alcohol OH, then NH, this one. Then we have also one more thing is this alkyne CH. So we are more interesting here this bond, and this is this one, and this is this one. How to remember this also? I can say the elements oxygen has a atomic weight around about 16. So this is related to this value. In that case we add a 200 or sorry, subtract 200, we are getting 3400. From here we subtract 100, we are getting a value 3300 centimeters. Now individually if we see, the in case of alcohol is a main element or a functional group which is ready to make the hydrogen bonding. So we further divided two types. Without hydrogen bond we are getting very sharp signal round about 3000 and 600 centimeters. If it form this hydrogen bonding, with this hydrogen bond it form a range from, because hydrogen bonding will decrease the wave number value, because I have, suppose this is my hydrogens, okay, and another one is here, this is like this. So this will form this bond. When they make the bond, this bond length is little bit increase. If increase bond length, we require a less amount of energy to stretch it. So we are getting a range that is less than 3500 to 3000, and that is very intensity is very variable. In case of amines and amide, they have a nitrogen and a hydrogen. So here nitrogen is less electronegative, oxygen is more electronegative, so it requires more value. It's a little bit less electronegative, so it requires little bit less a value. So there are primary amine, then it give a doublet. Secondary amine, it will give a singlet, and tertiary amine, it will give a no signal. Why it is such? This primary amines always there are, we get the signal structure like this. So one signal we are getting for this one and another signal we are getting for this one. In case of secondary amine, always we have such a type of compound. So in this case, what we are getting? We are getting a stretching between this. So we are getting one signal. In this case, for this one and for this one. And there is no signal because in case of tertiary, we have a no nitrogen and hydrogen. So we are not getting a signal here. In case of alkyne, dear student, here we have more confusions about that. Suppose I have compound like this. First, I will tell you what I am not interested here. I am not interested in this bond. I am more interested between sp3 carbon, sp3 carbon and hydrogen. Sorry, sp carbon and hydrogens. If you see it, the value is, and we are getting very strong intense peak. So whatever we had seen here, that I show you a pictorial diagram. If we see here, then in case of this, first we see the hydrogen. So in case of hydrogen, we are getting the intense signal round about this. This is nothing but a without hydrogen bond, and this is a with hydrogen, right? With hydrogen bonding, is it? The second thing is in case of amine. If we discuss about amine, then this green color, there we are getting a doublet. One is for this one. So doublet is always we are getting for NH2. And for NH, if you see here, we are getting what? A very singlet form. We are getting a singlet. The black color shown at here, that shows us a alkyne CH3. Alkyne CH3. If you see here, then it indicate the alkyne CH3. Alkyne CH. So this is a one pictorial diagram which I have tried to explain. Let us move zone number 2. So zone number 2 is starting from 3000 to 2500. It is further divided into aryl vinyl sp2h, alkane, aldehyde and carboxylic acid. Dear student, if we see here, aryl, a vinyl is like this. Vinyl is like this. So I can say this stitching. We are discussing about this stitching. Then we have a vinyl also. A vinyl. After that we have aryl. So in case of aryl, I am discussing about this one. Okay. Then alkane. I have not interest in this. I have not interest in this. Then alkane. This is like this one. And I am more interested here is about this one. So I can say sp2 carbon or sp2 carbon make the strong bond. So and sp3 carbon compared to the sp2 make a little bit a weak bond. So I can say the sp2 carbon, that's value is more than, not only more than, equal to 3000 centimeter inverse. So it can be a more than 3000. Then I can say this is sp2 carbon hydrogen. Then less than 3000, then I can say it is due to sp3 carbon and hydrogen. So aldehyde and ketones, okay, in case of aldehydic hydrogen, this is very characteristic signal. And to remember, I can say you like that. Suppose a COH, this is an aldehydic proton. So I am always try to remember in such a way. The carbon has 12 atomic mass. This has a 16. The value is 28. So less than 28, that is 27. More than 28, that is 29. So we are getting the very characteristic signal both at 2700 and 2900. Then after that, carboxylic acids we have. So carboxylic acids OH, we get its a broad peak stretching from less than 3000 to 2500. because in that case, it due to intramolecular hydrogen also, it will give a signal at here. But this is a little bit important. These three are very important: less than 3000, more than 3000, and atomic weight summations that will give some idea to us. Let us go ahead. And this is due to conjugations. Due to OH peaks occur at lower frequency than the zone 1 OH because it is a conjugated. I will show you what is the effect of conjugations. Conjugation always a lower the energy. How? That I told you. Let us go a zone number 3, and zone number 3 is very important and very interesting for us. I can say zone number 3, this is 3, it is useful for the triple bond. It is useful for the triple bond. And from 2000s to the 3000, we have make the story in zone number 2 about 3000. Now here we are discussing about 2000. So 2100 to 2260, we are getting very characteristic signal about carbon triple bond carbon H. And dear student, I again repeat you that I am not interested here in this carbon and hydrogen. I am not interested here. I am very interested now between this sp2 carbon and sp2 carbon. Okay, so if my compound containing a nitrogen, then chances of carbon triple bond nitrogen, and if my compound is not containing nitrogen, then chances would be a carbon triple bond carbon. So this is a little bit about a zone 3. Let us go about a zone 4. Zone 4 has a starting from 1500, then 2000 centimeter inverse. This is very interesting for carbon sp2, 2 carbon sp2, or any another elements with a double bond. Any another elements, carbon or oxygens or nitrogens, whatever it may be, we don't know exactly, but it could be. So this zone is divided. First is benzene. Benzene is on the borderline of this one. So I can say alkene, then carbonyl and aromatic. So here I can say, suppose this is my benzene. So somewhere my benzene are also getting a structure, in which case it this bond length here, it could be a giving a single bond like character due to resonance. So this is a carbon with hydrogen like a single bond, and we are getting. So in that case, this carbon and hydrogen single bonded, so it decrease a character from double bond to the single bond. Because if you see, this carbon is not single bond and not double bond, it is facing here double bond, but this is a single bond. So okay, we can say it does not face the double bond character, but it face a 1.5, which is a very weak compared to double bond character. So benzene carbon double bond carbon, we are getting a borderline 1500 to the 1600. Then alkene is completely double bond. There is no, if it is in conjugations, then also it is moved in these directions. But it is very simply, we can say it is a single carbon double bond carbon. Then it will gives more than that. So that is 1680, 1620. So little bit increase, more than 6000, 1600. That was a less than 1600. यहाँ पे कार्बोनाइल एक बहुत ही अच्छा फंक्शनल ग्रुप है. That value we are getting from 1630 से लेके 1850. We also do the discussion today in detail about these two range, because if we see about the carbonyl, then there are so many functional group: aldehyde, ketone, like this, aldehyde, then we have ketone, then we have carboxylic acids, then we have amide, then we have ester, then we have anhydride. There is lots of, I show you in detail also. So if this hydrogen bonding is occur in that case, then due to hydrogen bonding this value is decreased by 10 centimeter. That is also sometime important for us. Aromatic overtone, benzene is a borderline of that, and aromatic overtone is and over of this function, this range, so that we are getting about 1950, 1750. So this is a little bit helpful to us. Now among zone 4, the important point is this one. So here I want to discuss with you is, I have a functional group, acid halide, acid chloride, anhydride, ester, and amide. The carbonyl containing functional group. There are a little bit some more salts also there. So one I can say hydrogen. This is aldehyde. Then I have ketone. Then I have a carboxylic acid. So here among this all I can say Cl is in the period number 3. Carbon and oxygens, they are in period number 2. So here there is no chances of, or less chances of resonance or a conjugations. Very less chances. I can say here 100% is chances of conjugations, because it will gives it here. So what structure I get here? I get a structure like this. In case of here, I could get a structure like this. So here what I want to show you, here in case of amide, we see that a carbon and oxygen bond is going to be single bonded, and single bonded carbon and oxygen has value in a zone number 5, or we can say fingerprint regions. It is not in our interest of discussion, but my intention is, compared to carbon double bond O, the value is going to be decreased. Here this carbon oxygen double bond value is decreased, but here also we are getting the same value or same structure. So I can say we are getting a same character here. This lone pair is a tug of war between these two carbonyl group. So I can say it cannot move in any directions, and resonance effect is decrease. It will not give the resonance, but it will give this inductive effects. Due to inductive effects, Cl will withdraw the electron, so carbon will stretch here, the oxygen is also going to be stretched, so carbon and oxygen's bond length decrease, decrease, so bonds increase the strength. Due to increase a strength, due to increase a strength, it required a more energy, it required a more energy, it required a more wave number. So dear student, I can say here the inductive effect is predominant, here tug of war for the lone pair, so inductive effect is predominant. Here inductive effect is slightly dominates, and conjugations are strongly dominate. એટલે અહીંયા આગળ છે ને મિત્રો, we are getting a single bond character of carbon and oxygens. Second characteristic signal for the two peaks are this one. If we are getting the two characteristic signal, then we can say this is important values for possibilities of anhydride. So after discussing a technical point, we move to this exact value what we should have to take. So I suggest you carbon oxygen carbonyl value, we take 1500 1715 centimeter inverse. This is a base value. So here we discuss about it, and I told you a decrease or subtract 85, and here I told you add 85. When I subtract 85, I get 1620 centimeter inverse. Always centimeter inverse are there. And here I get 1800 centimeter inverse or more than that. बाद में इसमें हम we add a plus 15, 15 का double 30, then I can say plus 30, 30 का double 60, then I can say plus 60. So here we add a 15, we are getting 1730, यहाँ पे 1745, यहाँ पे 1775. Okay. So in the last slide we have seen a less value is for amide. So I can write here, yes, dear student, this is nothing but it is amide. This is what? This is a saturated ketone or carboxylic acids. Carboxylic acid carbonyl. Here what? Aldehyde. Here what we are getting? We are getting this ester. Here acid anhydride. This is acid chloride or acid halides. So this I have told you in both the way to recall it and to understand it with this conceptually. Another way to remember is we have carbon, then nitrogen, oxygen and a halogens. So I can say a nitrogen at here, so amide has less value. Then ketone and acid. So after nitrogen we have oxygens. Then oxygens we have here a hydrogen. So I can say aldehyde. Then we have ester. Then we have acid anhydride. Then we have acid halides. So simply if we will see here and it try to recall in such a way, the halogen it has a more, then we have two oxygen member acid anhydride ester, जिसका नाम बड़ा है उसकी वैल्यू भी बड़ी है, then ester, then acid is our milestone, then nitrogen is backward of the amide, so ये यहाँ पे आ जाएगा. In that way also we can remember. I have shown you technically, basically what happened, a double bond character is going to be lost by the carbonyl group, so we are getting a less value due to the resonance. So thank you for continuously watching a video for that, and such type of video I will try to make and share with you to get a continuous update. Please do subscribe so you get a continuous update for that. Okay, bye.